Let's talk about SQL queries. All right, so like the name suggests, SQL stands for Structured Query Language. It was an attempt at providing a very simple way to interact with databases so that they would sound or would look like or read somewhat like an English-like language instead of using relational algebra, right? This has a little more human flavor. But the basic structure of queries that have the following clauses. We have the select clause and the from clause, right? And the idea is that we want to presumably store data in the forms of tables and records, and then we want to be able to retrieve them, right? We want to be able to read from them. And so basically, a SQL query allows you to filter out information that has been spread out over multiple tables, right? Has been spread out into multiple records, and be able to identify which of those tables and which of those records in those tables do we really want, right? So it's a filter, a transformation from multiple data sets into a single data set. Okay, which tables and which records meet a particular criteria. So again, we're going to be using our toy SQL relational database here, representing our toy university with students and departments and courses, sections, and enrollments. So here's an example of a query, right? That it's retrieving several things, right? We are retrieving a couple of records, right, that meet the following criteria. Actually, there is no criteria, right? Notice that this says, select for me all the student names and their graduation year from the data set called student. So presumably there's a table called student, and I want all the records. Notice that I'm not discriminating which record. I'm not providing any criteria. That means I want all of them, right? All I believe 9 students in our database, right? So I want all 9 students. But notice that I don't want all the fields, right? I want only the student name and the graduation year. I don't care their major ID. I don't care about any other fields that might be there. That's right. I just want all the records. Notice also that we are prefixing the field that we want. We're prefixing it with the name of the table. So student name, right? We only really need that prefix of the name of the table only if there's is there any ambiguity, right? If you have 2 tables that you're retrieving information from, and there are 2 fields that have the same name on both tables, then we would need to have a prefix in front of it, right, to disambiguate. Otherwise, the name of the table is optional, right? We don't have to provide it. Also, some of these tables might have really long names, and we can abbreviate them, right? When in the from clause, we can give it an abbreviated keyword or single character, so that we can use it in the prefix. Is much more convenient. Okay, but later on we'll see that there's actually an absolute must that you need to rename them, right? That you need to name, especially if you have in the from clause, you want to be able to use the same table again, right? Where you're providing like a self join. For instance, if you have a hierarchical data structure where you have employees and their managers, right? Typically, you would have it in the same table because everybody's an employee, right? But some employees are managers of other employees, right? And those employees might be managers of other employees. So that you have a hierarchy, right? So if you want to be able to retrieve information about who's the manager of who, you need to be able to join or create relationships of records in one table with records on the same table, right? So oftentimes, right, we need to specify the same table twice. So where student, where it might be the employee table, and you say employee manager, comma, right, employee, right, and then you want to say, well, I want the records whose employees are for this particular manager, right? So whenever you do self joins, then definitely you need to rename them because you can't have the same table twice. A couple of shorthands. First of all, if there's no ambiguity on what field are you talking about, right, on what table you're referring to, you can just drop the name of the table in front of it. Okay. Also, if you want all the fields, right? Then it'd be very cumbersome having to specify every single field, right? So you can just use star. Star means you want all the fields, or you might want, if you have more than one table, you might want all the fields from one of the tables, but then only a few fields from the other table, right? So you can say, table.star if I want all the fields from that particular table, comma, and then the rest of the fields from the other table. Make sense? So I can be, as specific as I want which fields I need. Now, if you have multiple tables, right? Maybe you have department and employee. Here, for instance, the department, the primary key is ID, and you have the employee name ID. If employee and department might have had the same field name right, where the employee has a name and the department has a name, then you would have to have prefix the name of the table. But luckily here, both the department it has a D name instead of name, so there's no ambiguity. So there's no need to prefix it. Yes. But notice that also ID and DID also there's no ambiguity there. But if they were, then we have to prefix it. Here's a couple examples of select star from persons. So our person has three folks, Alice, Bob, and Charlie. So select star from persons just returns the entire table and all the fields in that table. Whereas here, if you're saying select just last name and first name from person, then you only get back only those two particular fields from that particular table. Any questions? Okay. Sometimes some of the information that's coming through might be repeated, especially if you're referring to a single field, right? And that field is not a primary key. Often, chances are that field might have repetitions in there, right? Or duplicates. So, for instance, if you say select city from persons, it might be that there's quite a few folks that live in Lowell, right? But you can ask it that maybe I want distinct, meaning make sure that the results are distinct. Obviously, this query is much more expensive than this one, right? Because in this one, it needs to iterate over the result set, and whenever it's going to add to the result set, it needs to see is it already there. It needs to iterate over the entire result set to see if it's not there. If it's not, then it adds it. Otherwise, it doesn't. So this is much more expensive, right? Yes. No, we'll take a look at group by in a minute. Yep. But no, it's not the same. There's a couple SQL data types. Most major data types are supported. Numeric, small int, doubles, floats, integers, strings, varchar, and whatnot. These are constraints that you can put on the data, on the fields. Right? Saying meaning, make sure that this field is a date, right? Or it's an integer, or it's a double, or it's a whatever it is, or it's a particular size, right? So that's one of the many constraints that we can put in the data. It also, most vendors will have a library of multiple functions that allow you to operate on dates, operate on numbers, all sorts of arithmetics, on string manipulation, date manipulation. So all sorts of functions as well. You can calculate the lowercase, trim, character. There's a slew of functions that are available for string manipulation, and we'll introduce them as we need them. But just here's just a couple. These are substring. Again, you can calculate the substring instead of a bigger string. There's a couple of variables that are available all throughout the system, like current user. Whoever's currently logged in, the username. This always returns the current user. You can also ask for the current time, right? Wherever the machine is running, right, in milliseconds. All that can be part of the information that you can use in your select statements, right? So that you can say, well, if I log in and I want to see my students, then my query might return only the courses that I'm teaching, only the students that I'm helping out, right? If somebody else logs in, current user would return their courses, their students, and whatnot, right? // you can concatenate strings. Allows you to pattern match strings with some of these special characters, percentage and underscore, right? So to see if it's they match. Here's a couple examples of the pattern matching. allows you to say, ask whether a particular string matches another string, right? Einstein, you want, maybe you can pattern match it with any single character followed by I, then followed by any number of characters, followed by I, followed by one character. So that matches Einstein. Or it also matches some of the other strings here. We'll use like quite a bit when we are talking about the where clause in a little bit. Oh, here's the where clause. So before we talked about the select and the from clause, right? Select allows you to specify which fields you want, whereas from tells you what tables am I getting the information from, right? And by default, it grabs everything, all the records, right? What's worse, if you have two tables, by default, the interpretation is that you want to relate every record in one of the tables with every record with the other table, which might make no sense, right? If you have two tables, that might have certain relationships, right? That you might have users here, U1 and U2, and you have here, so this is users, and this is the department table, D1 and D2, and U1 is enrolled in that department, and this U2 is enrolled in that department, right? If you select U1 dot first name and U2 dot first name, I'm sorry, just U dot first name, right? And you say from U and comma D, right? And your first name, and also you want their department ID, or maybe the department name. So you want to know where they belong to, what name of the department. And just like that, then you would be given every single match between everyone, right? So you would be given U1 the first name, and then department 1 name. Also, U1 first name and department 2 name, which makes no sense. I'm sorry. This one makes no sense, right? Because the user 1 is not related to department 1, right? It's only related to department 2. And here you would get U2 first name and department 1 name, which is we want, yes. But you also get first name D2 name, which makes no sense, right? Because U2 is not related to department 2. Okay, but that's what happens if you don't put a where clause, right? In the where clause, you might say, I only want the ones where the user, right? This line here, that means that there's a foreign key here, all right? There's a primary key here, there's a foreign key here, there's a primary key here, where my user's foreign key is equal to the department's primary key, right? That filters out and says, well, no, I don't want these, right? I only want the ones that relate. Yes. So without the where clause, what do you get is a cross multiplication, right, of all possible relationships, right, all possible combinations, right, of permutations of all the records on the left-hand side with all the records on the right-hand side. Make sense? Right, because effectively, to implement this where clause, how is that implemented? Well, I need to start with U1. Right? If I'm checking to see if this is true, I need to say, well, let me check with this one, with that one. Right? I have to consider it. Is this true? No. All right, so I'm not taking that. Then I have to iterate. Then I go to the next one. For this U1, we'll look at D2. Does that meet this criteria? Yes. So I'll take that. Then I have to go to U2, do the same thing. Iterate with this one, iterate with that one. Right? Basically, I have two nested loops. Yes, you have an outer loop that iterates over the users, and an inner loop that iterates over the departments. Right. So to implement this, it's order square, n squared, right? The complexity. So imagine now that I'm putting here courses. Which is I want the users, the department, and the courses that they're in, right? Or maybe sections, maybe the sections, section 1, section 2, right? That means that I'm iterating. There's 3 nested loops now, right? So it becomes exponentially hard, right? So it's n squared, n cubed. So every time you add an additional, right, an additional table, yeah, you are adding complexity on how is it that you're going to iterate over that, right? That's why we'll talk about indexing, and we'll talk about a couple of strategies on be careful, right? They can be very, very expensive. Anyway, so with a where clause, right? All to say that with a where clause, you can filter out and say, well, I want only these subsets, right, of the fields. Right. So the like pattern allows you to say, well, I only want the column name that pattern matches the right hand side of that pattern. Right? And again, we'll play around with some of this. So here's an example. I want the persons whose city starts with LO. Okay. Also, you have to be careful, right? The shorter the string is, right, the harder, right, the longer it takes for this to pattern match. Right, the longer the string is, the shorter the time it takes to pattern match. Yes, because if you have just L, there could be lots of things that match just with a single character. Right, so the bigger this is, the faster it is that it can pattern match. So be careful with like, right? It could create very, very expensive queries. Date types, every vendor supports a representation of date. The format typically is 4 characters for the year, dash 2 characters for the month, dash 2 characters for the day. Although different vendors will have additional formats, right, to support date and time, or timestamps, or formats such as military, or European, and many other formats. Also, most vendors will provide mechanisms that allow you to do operations, arithmetic operations on dates, so you can count intervals as days, weeks, months, years, or calculate, given the date today, what's the date 9 months from now, right? And you can do, and you can also do filters such as, is it a business day? Is it a holiday? It has all these calendars. Some vendors are very powerful, and they'll have calendars depending on the regions, so they'll know if it's a holiday on that particular region, right? And you can do all sorts of really cool logic around that. So you can ask for the current date as well. Very useful when you're inserting. Usually, oftentimes, to do like an audit, whenever records are being inserted or updated, oftentimes you could use very common to have additional fields that will record when was this record first created, right? So created at or updated at, right? That will allow you to automatically tag when was the last time that this was modified. And you can do all sorts of operations. You can extract the month, the year, the day. You can do intervals such as given the first particular date, add 7 months, right, and gives you the date. It knows about leap years and all those kinds of things. Same thing, interval 5 days. You can do subtraction as well. Subtract one against the other, it gives you how many days there are. All sorts of formats. Again, different vendors will have different formats that are supported, but everybody supports the most common ones, right? Date, time, and timestamp. Plus, SQL Server will support some additional date formats. Each vendor will have different functions that can operate on dates. Getting the current date, the current time, date extract, add, subtract. Here's a couple from SQL Server. So I'll only point them out whenever we need, depending which vendor we're talking about. But for the most part, you can pretty much do everything from one to the other. Here's an example of converting between dates and whatnot. This is on SQL Server, and then convert will do the conversion between a string and the dates, but it also allows you to format it depending on different regions. Right? This is the and whether it's a European I think it's a day, month, year, as opposed to month, day, year, right? Or they use the dot instead of the slashes or dashes, and you can format it in any which way. All right, so let's go back to the select statement and let's use some of these operations. Here's a, I'm retrieving from the student. I'm retrieving all the records from the student, right? I'm calling it S. And as I am retrieving, I'm retrieving all the fields in the student. Here, I'm using the as keyword where I can create brand new fields. You know, as I am iterating over this data, I can calculate it on the fly, right? So I can create new data sets on the result set, right? I'm not inserting anything in the database, but as I'm querying this data, I can create a brand new record, new fields, grad class, which is calculated from subtracting the year that the student was graduated minus the year that the institution was founded. So it was founded in 1863. So the graduating class, I'll get the year minus that year, plus the college, you know, Boston College, you know, having a particular value, specific value, right, and calling that field as college. I can do additional transformation. Well, here's the result. Here's a sample result. The graduation year, you're the 153rd graduating class, right? Based on when you're graduating, their major, the student name. So let's look at an example of you know, looking at this all these fields that I'm retrieving, but then doing some transformation. So for instance, I can rename the field from the old SID. I can rename it, right? And I can create a column called new SID, which has the same value as the old ones plus the S name. Also the graduation year, I'm renaming it as the graduation decade. I'm going to do some arithmetic to calculate what decade did you graduate, right? We're going to do some arithmetic there. So first of all, to create the new student ID, I'm going to prepend whatever student ID I had earlier. I'm gonna concatenate the string student hash, right, and then the original SID. And to do some arithmetic, I'm going to take the old graduation year. I'm going to divide it by 10. I'm going to cast it as an integer, so I'm going to drop the decimals, right? I'm going to drop those, and then I'm going to multiply by 10 again. So if you graduated, you know, in 2003, right, then that would be the decade of 2000. Right? If you graduated 2000 and 7, yeah, you're still in, you know, in the 2000s. Yes. So basically, I want to calculate that, did you graduate in the 2000s, 2010s decade, 2020s, 2030s? What decade did you graduate? So that allows me to do that calculation. So there it is. So here's student Joe, Amy, and whatnot. Here's the graduation decade. They all graduated in the 2000s. A couple other operations. There's a case when. Very much like you know, in programming, you have if statements and cases. You know, switch case. You can also embed in your select statements. You can embed cases and if statements, right? Where the values can be based on the data that you're iterating over. So if you're iterating over some field, right, you can use it in your where clause to check the condition, whether it's greater than, less than, or whatnot. And depending on the value, you can trigger several when clauses, and then a default else. So here's a real quick example. You know, so you know, imagine we had a table that has a single value A, a single field A with these three values, 1, 2, 3. Imagine we have this table A with 1, 2, 3. For instance, we can have a select A. Right, so that returns the original value, 1, 2, and 3. Right, so that's the result of just 1, 2, and 3. So grab me the first field, just 1, 2, 3. And in the case, the second field, the case here, if it's 1, then the value is going to be 1. If it's 2, it's 2, and if it's anything other than 1 or 2, it just returns other. So it comes out to, you know, 1, 2, and other. So I can on the fly make these kinds of logical statements inside of my select. There's two different syntax. There's this syntax where you where you can do the you can compare these Boolean expressions are individual on their own. Yes. So that's based on the name of the function that you're using, case. Oftentimes you want to specify an actual name. So you could put an as, as, and then the actual name of the field that you want. If you don't do that, it'll choose a name for you based on the name of the function that you are running. So there's this syntax where these could be individual predicates, right? Individual predicates, or another syntax where it's more common to what we already know of the switch case statement, where you only have a single expression, and then that expression is compared against multiple values, right? Just like a switch case, right? So that could be a constant that gets compared against multiple values, and if it's equal to one of them, then you can return the result. So here it is. You have you can rewrite the same thing we had earlier, and compare A against 1, 2, and then have the else other. All right. So here's a continuing a little bit on the same example as we had earlier. We like to calculate the whether the student is an alum, right? Whether they have graduated already, or whether they're still in class and they're still enrolled. They haven't graduated yet. So here we are. What we're doing here is that we're extracting the current date, right? Maybe 2019, 2020, and we're extracting the year, and then we're subtracting from that when is their graduation year. Are you graduating 2018? Are you graduating 2022? We're subtracting that, and depending on the value, we're going to determine whether you're an alum or not, right? So if your graduation year is in the past, then you're an alum, right? If your graduation year is in the future, then you're not an alum, right? So let's see. We're subtracting it, and so if the current year is 2011, then we're subtracting 2007 from that. We get a 4. We get a 4. And then we can use that expression. We can use that expression in a case, right? We're saying, take that table Q69 that we had earlier, right? This query here, this whole thing, put it in a parentheses, right? We're going to reuse it. You can take that select statement, and we're going to use it in the from clause, right? We're using it in the from clause. We're going to call it Q, and we're asking, right? If it's positive, that means your graduation year is in the past, right? Although it's positive, then you are an alum. Whereas if it's negative, that means your graduation year is in the future, and then you're not an alum, right? You're still in school. And we're going to rename that field as a graduating status, right? So that's the result of the graduating status. So notice that this is the first example we look at a select statement used instead of another select statement, right? Which is perfectly fine. Typically, the syntax would be that you copy this exact select statement, okay? And you can just put it in here. You can put it in parentheses. You can put a parentheses and put the entire select statement here. So you can nest select statements inside of other select statements, which is pretty cool. The more common way that we're going to do it is instead, if we find certain queries to be very useful and we want to reuse it like that, typically we create a view, which is the equivalent of naming a query. Right? Here's a query. I want to give it a name, right? And then I want to treat it as if it were a table. And this is exactly what we've done, right? But we'll see that a little later when we talk about views. Equivalent. There's also an if statement as well. So there's the case. There's a two syntax of case. But you can also use an if statement. It's much more compact, right? Much more terse. Select star, comma, and then the graduating status is take Q. Is it positive? It's an alum. If it's not positive, then it's an in school. Very much like Excel, right? We have an if statement where it's true, and you have a true clause, and then you have false clause, right? Very much like Excel. And then you can name it. You can name the field whatever you want. All right, excellent. Let's take a look at joins.